Hi friends, today we are learning about the exponents and powers of class 8. This topic is divided into 4 parts. In first part, we'll learn about the meaning of exponents and powers, why do we study exponents and powers, representation of numbers in standard form, laws of exponents, and some questions. Now let's understand the meaning of exponents and powers. In this example, 10 raised to the power of 24, 10 is the base and 24 is the exponent. Then what is power? You might say that 24 is also called as power, but 24 is an exponent. Whole thing, 10 raised to the power of 24, whole thing or whole expression is called as power. We just read it as 10 raised to the power of 24, but it doesn't mean that 24 is a power. 24 is an exponent. Now what is the meaning of 10 raised to the power of 24? It means we have to multiply 10 by itself 24 times. That is 10 into 10 into 10 into 10, we have to multiply itself 24 times. Now let's understand why do we study exponents and powers. It is very difficult to read, write, compare, and understand such big numbers. We use exponents and powers to make it easy to read, write, and even to compare. This mass of the earth, 5972190000000 can be written as 5.97219 into 10 raised to the power of 24. This form is called as standard form. And this is called as usual form. It is very difficult to read, write, and even to compare numbers in usual form compared to standard form. Now let's learn how to convert this usual form into standard form. Before going to the conversion of usual form to standard form, let's know some points about the standard form. Standard form have the format of m into 10 raised to the power of n, where m is any decimal number, where m has to be greater than or equal to 1 but less than 10. M has to be greater than or equal to 1 but less than 10. N can be either a positive or a negative exponent. The exponent n can either be a positive or a negative exponent. Now let's take an example. Now size of a bacteria is 0.00000005 meters. It is very difficult to even to read such small numbers. Now let's convert this usual form into standard form. Since m has to be a decimal number, let's take this decimal point beside the number 5.0. We took the decimal point beside the number 5 because 5 is greater than 1 and less than 10. So it's better if you write 5 into 10 raised to the power of n. N is an exponent where it can be either a positive or a negative. Now how to decide that the n has to be positive exponent or a negative exponent? So when we change the position of the decimal point towards right side, that is from left to right, if we change the position of the decimal point, then the exponent n will be as negative. If we move the decimal point from the right to left, then the exponent n will be a positive. In this case, we are moving the decimal point from the left to the right to change it into standard form. So the exponent n will be in negative. So let's write here minus. Now what is the value of n? The value of m says how many places we have shifted the decimal. Like 1, 2, 3, 4, 5, 6 and 7. We shifted this decimal point 7 times so that it can come beside 5. So this will be like 5 into 10 raised to the power of negative 7. Now let's take another example. Size of a plant cell is 0.00001275 meters. We have to take this decimal point beside 1 because 1.275 is greater than 1 and less than 10. If we take the decimal point beside 2, that will be like 12.75. 12.75 is greater than 1, but it is not less than 10. So the value of the m will be as 1.1275. 275 into 10 raised to the power of n. N can be either a positive exponent or a negative exponent. In this case, n is a negative exponent because decimal is moving from left to right to change it into standard form. So let's write a minus sign. Now let's see how many places we have to shift the decimal point so that it comes beside 1. This is 1, 2, 3, 4 and 5. 1.275 into 10 raised to the power of minus 5. Now let's take another example. Mass of the mass is 6390000. Let's convert this into standard form. This has to be 6.39 because 6 is greater than 1 and less than 10. If it will be 63.9, 63 is yes greater than 1 but it is not less than 10. So we have to get a decimal point after 6. But since there is no decimal point in the number, let's take a decimal point at the end of the digit, 0.0. Now the decimal point has to move from the right to left to change it into standard form. If a decimal point moves from the right to left to change it into standard form, then the exponent will be in positive. Now let's write the value of m. Value of m is 6.39 into 10 raised to the power of positive n. Now let's see how many places we have to shift the decimal. 1, 2, 3, 23. 6.39 into 10 raised to the power of 23 is the mass of the mass. Now let's move to some more examples. Distance between our house to a school is 1200 meters. Now let's convert this 1200 meters into standard form. So since there is no decimal, let's take a decimal at the end of the number, 0.0. This decimal has to come beside 1 because 1.2 is greater than 1 and less than 10. So this is 1.2 into 10 raised to the power of positive or negative n. Since the decimal is moving from the right to left, the exponent will be in positive. So let's see how many places it has to move. 1, 2 and 3. 1.2 into 10 raised to the power of 3. When we move the decimal points towards the left side to change it into standard form, then the exponent will be in positive. If we move the decimal points towards the right side to change it into standard form, then the exponent will be in negative. Let's move to the sum of the points which we have to memorize. A unit prefixed by giga is equals to 10 raised to the power of 9. 1 gigameter, 1 gigaliter is equals to 10 raised to the power of 9. 1 megameter, 1 megaliter is equals to 10 raised to the power of 6. 1 kilometer is equals to 10 raised to the power of 3. 1 millimeter or milliliter is equals to 10 raised to the power of negative 3. That is 1 by 10 raised to the power of 3. 1 macrometer or a macroliter is equals to 10 raised to the power of minus 6. That means 1 by 10 raised to the power of 6. 1 nanometer or nanoliter is equals to 10 raised to the power of minus 9. That is 1 by 10 raised to the power of 9. Now let's take an example relating to this. The volume of this medicine is 10 milliliters. Now let's see how many liters are a milliliter. In this case, milliliter is smaller unit than the liter. 1 milliliter is equals to 1 by 1000 liters. 1 milli is equals to 10 raised to the power of minus 3, that is 1 by 1000. Then 10 ml is equals to 10 by 1000 liters. We can write it as 10 into 10 raised to the power of negative 3, because 1 ml is 10 raised to the power of negative 3. liters, then 10 milliliters equals to 10 into 10 raised to the power of negative 3 liters. So this will be like 0.01 liters. This is another example of changing usual form into standard form. Now let's move to some Funmatics. What if the exponent is 0 or 1? We know when the exponent is 2, we have to multiply the base 2 times. When the exponent is 3, we have to multiply the base 3 times. But what if the exponent is 0 or 1? For any number raised to the power of 0, any number raised to the power of 0, the value is always 1. Any number, let it be 10,000 or 1 lakh raised to the power of 0, the answer will always be 1. 1 raised to the power of 0, the answer is 1. 0 raised to the power of 0, answer is 1. 100 raised to the power of 0, answer is 1. Minus 1 raised to the power of 0, 1. 4 raised to the power of 0, 1. 5 raised to the power of 0, 1. 1000 raised to the power of 0, 1. 1 by 13 raised to the power of 0, it's again 1. For any number raised to the power of 0, the value is always 1. Now we know the answer for the exponent as 0. Now what if the exponent is 1? For any number raised to the power of 1, x raised to the power of 1, the value is always the base itself, that is x. Minus 10 raised to the power of 1, the answer is minus 10. Minus 1 lakh raised to the power of 1, the answer is minus 1 lakh. 100 raised to the power of 1, 100. Minus 1 raised to the power of 1, minus 1. 100 raised to the power of 1, it's 100. 10,000 raised to the power of 1, it's 10,000. 1 by 10 raised to the power of 8 whole raised to the power of 1, it's again 1 by 10 raised to the power of 8, that is the base itself. Now let's say some powers. It is good to memorize these powers so that you can do the problems or you can solve the problems faster. 1 raised to the power of any integer, that is 1 raised to the power of 0, 1 raised to the power of 10, any integers, the answer will be 1. 1 raised to the power of 100, the answer is 1. 2 raised to the power of 0, any number raised to the power of 0, the answer will be 1. 2 raised to the power of 1 is the 2 itself. 2 raised to the power of 2 is 2 into 2, which is equals to 4. 2 raised to the power of 3, this can be written as 2 raised to the power of 2 into 2, which is equals to 4 into 2, which is equals to 8. 2 raised to the power of 4 can be written as 2 raised to the power of 3 into 2. 2 raised to the power of 3 is 8. 8 into 2 is 16. Now 2 raised to the power of minus 5 can be written as 2 raised to the power of 4 into 2, which is equals to 16 into 2, that is 32. 2 raised to the power of 0 or any number raised to the power of 0, the answer is 1. 2 raised to the power of 1 is 2 itself. 2 raised to the power of 2 is 4. 2 raised to the power of 3 is 8. 2 raised to the power of 4 is 16. 2 raised to the power of 5 is 32. Now let's move on. 3 raised to the power of 0. Any number raised to the power of 0 is 1. 3 raised to the power of 1 is 3 itself. 3 raised to the power of 2 is 3 into 3, which is equals to 9. 3 raised to the power of 3 is equals to 3 raised to the power of 2 into 3, which is equals to 9 into 3, which is equals to 27. 3 raised to the power of 4. 3 raised to the power of 4 can be written as 3 raised to the power of 3 into 3, which is equals to 27 into 3, which is equals to 81. 3 raised to the power of 5 is 3 raised to the power of 4 into 3, which is equals to 81 into 3, which is equals to 243. 3 raised to the power of 0. Any number raised to the power of 0 is 1. 3 raised to the power of 1 is 3 itself. 3 raised to the power of 2 is 9. 3 raised to the power of 3 is 27. 3 raised to the power of 4 is 81. 3 raised to the power of 5 is 243. Now let's move on. 4 raised to the power of 0 or any number raised to the power of 0, the answer is always 1. 4 raised to the power of 1 is 4 itself. 4 raised to the power of 2 is 4 into 4, which is equals to 16. 4 raised to the power of 3 is equals to 4 raised to the power of 2 into 4, which is equals to 16 into 4, which is equals to 64. 4 raised to the power of 4 is 4 raised to the power of 3 into 4, that is equals to 64 into 4, which is equals to 256. 4 raised to the power of 5. 4 raised to the power of 5 is 4 raised to the power of 4 into 4, which is equals to 256 into 4, which is equals to 1024. 4 raised to the power of 0 is 1. 4 raised to the power of 1 is 4 itself. 4 raised to the power of 2 is 16. 4 raised to the power of 3 is 64. 4 raised to the power of 4 is 256. 4 raised to the power of 5 is 1024. Let's move on. 5 raised to the power of 0 or any number raised to the power of 0, the answer is 1. 5 raised to the power of 1 is 5 itself. 5 raised to the power of 2 is 5 into 5, that is equals to 25. 5 raised to the power of 3 is 5 raised to the power of 2 into 5, which is equals to 25 into 5, which is equals to 125. 5 raised to the power of 4 is 5 raised to the power of 3 into 5, which is equals to 125 into 5, that is equals to 625. 5 raised to the power of 5 is 5 raised to the power of 4 into 5, that is 625 into 5, which is equals to 3145. 5 raised to the power of 0 is 1. 5 raised to the power of 1 is 5. 5 raised to the power of 2 is 25. 5 raised to the power of 3 is 125. 5 raised to the power of 4 is 625. 5 raised to the power of 5 is 3145. Laws of exponents. We use the laws of exponents to easily solve the expression or the operations. Now let's see those laws of exponents. Laws of exponents can be done under multiplication, division, and negative exponent. In multiplication, we have three laws, in which the first law says that a by b are any rational number where b is not equal to 0, and m and n are any two integers. In first law, we have the bases same but the exponents are different. So then we have to write the base as it is and we have to add the exponents. Let's take an example. 3 raised to the power of 2 into 3 raised to the power of 3. This is equals to 3 raised to the power of 2 plus 3, which is equals to 3 raised to the power of 5. That is equals to 243. Now let's take another example. This time let's take a fraction. 3 by 5 raised to the power of 3 into 3 by 5 raised to the power of 4. This can be written as 3 by 5 raised to the power of 3 plus 4. This is equals to 3 by 5 raised to the power of 7. Let's move to the second law. In second law, there is a power which is again raised to an exponent. Then we have to multiply those two exponents. Let's take an example. 3 raised to the power of 2 whole raised to the power of 3. This we should write it as 3 raised to the power of 2 into 3, which is equals to 3 raised to the power of 6. Let's take another example. 3 by 5 raised to the power of 2 whole raised to the power of 4. This is equals to 3 by 5 raised to the power of 2 into 4, which is equals to 3 by 5 whole raised to the power of 8. Now let's move to the third law of exponents in multiplication. This time we have the exponents same whereas the bases are different. Then we have to group the base and remove the common exponent. Let's take an example as 3 raised to the power of 2 into 4 raised to the power of 2 is equals to 3 into 4 whole raised to the power of 2. That is equals to 12 raised to the power of 2, which is equals to 144. Now let's take another example. 3 by 5 raised to the power of 2 into 5 by 3 raised to the power of 2. This we can write as 3 by 5 into 5 by 3 whole raised to the power of 2. I'll get cancelled. 3 will get cancelled. This is equals to 1 raised to the power of 2, which is equals to 1. Now let's see the laws of exponents in division. In division we have two laws of exponents. In first law we have the same base, whereas the exponents are different. When we have the same base and the exponents are different in division, then we have to subtract those exponents. In multiplication, when we have the same base, we have to add the exponents. In division, when we have the same base, we have to subtract the exponents. Let's take an example. 3 raised to the power of 3 divided by 3 raised to the power of 4. This we can write as 3 raised to the power of 3 minus 4, which is equals to 3 raised to the power of minus 1. Let's take another example as fraction. 3 by 5 raised to the power of 4 divided by 3 by 5 raised to the power of 2. This is equals to 3 by 5 whole raised to the power of 4 minus 2, which is equals to 3 by 5 raised to the power of 2. Now let's go to the second law of exponential division. This law can be used only in a fraction. Let's take an example. 3 by 5 whole raised to the power of n. This we can write as 3 raised to the power of n by 5 raised to the power of n, or 3 by 5 raised to the power of 2. We can write as 3 raised to the power of 2 by 5 raised to the power of 2, or even vice versa. Now let's move to the rule where we'll have a exponent sign as a negative. When the sign of the exponent is negative, to do the further operations or to solve the problem, we have to convert that exponent into positive. To convert those exponent into positive, we have to reciprocate the base. Let's take an example. 3 raised to the power of minus 2. This can be written as 1 by 3 raised to the power of 2. Let's take another example. Let's take a fraction. 3 by 4 whole raised to the power of minus 3. This we can write as 4 by 3 whole raised to the power of 3. To make these exponents into positive, we have to reciprocate the base. That is, 3 will become 1 by 3 and 3 by 4 will become 4 by 3. Let's move to some of the questions now. Evaluate 3 raised to the power of minus 2. 3 raised to the power of minus 2. This minus 2 has to be changed into positive 2, for which we have to reciprocate the base. This will be 1 by 3 whole raised to the power of 2. Since they said to evaluate, they have to find the value of this power. 1 by 3 whole raised to the power of 2 is equals to 1 raised to the power of 2 divided by 3 raised to the power of 2, which is equals to 1 by 9. Let's move to second one. Minus 4 raised to the power of minus 2. Again, we have to convert the negative exponent into positive, which is equals to 1 by minus 4 whole raised to the power of 2. If there is no denominator, take the denominator as 1. Then this is equals to 1 raised to the power of 2 by minus 4 raised to the power of 2. 1 raised to the power of 2 is 1 itself, minus 4 raised to the power of 2. Now 4 raised to the power of 2 is 16, but minus 4 raised to the power of 2 is positive 16 or a negative 16. Now look at the top of the slide. If we have a negative base raised to an odd exponent, negative base raised to an odd exponent, then we will have result in a negative. If there is a negative base raised to an even exponent, then we'll have a result in positive. Note this point. If we have a negative base with odd exponent, then we will have a negative result. If we have a negative base with even exponent, then we will have a positive result. In this case, minus 4 raised to the power of 2. 2 is an even number, so this will be as a positive 16. Now let's move to the third one. 1 by 2 whole raised to the power of minus 5. We have to convert this minus 5 into positive 5. For that, we have to reciprocate the base, which is equals to 2 raised to the power of 5. That is equals to 32. Let's go to the next question. Simplify and express the result in power notation with a positive exponent. This time we don't need to find the value of the power. If we simplify that power, it's enough. We have to simplify and express the result in power notation. Power notation means a raised to the power of n with a positive exponent, that is n has to be a positive exponent. Now let's move to the first one. Minus 4 raised to the power of 5 divided by minus 4 raised to the power of 8. This we can write as minus 4 raised to the power of 5 minus 8, which is equals to minus 4 raised to the power of minus 3. We got the result in power notation. But we didn't get it in a positive exponent. So we have to convert this negative exponent to positive. For that, we have to reciprocate the base. 1 by minus 4 raised to the power of 3. Now we don't need to find the value of 1 by minus 4 raised to the power of 3, since they have said to simplify and express the result in power notation. Now let's move to the second one. 1 by 2 raised to the power of 3 whole raised to the power of 2. As I said before, when there is a power raised to an exponent, we have to multiply those power. This is equals to 1 by 2 whole raised to the power of 3 into 2, which is equals to 1 by 2 raised to the power of 6. Now we got the result in power notation, where it is a positive exponent. 6 is a positive exponent. Let's move on. Third one, minus 3 raised to the power of 4 into 5 by 3 whole raised to the power of 4. Since the exponents are same, let's group the bases. Minus 3 into 5 raised to the power of 3 whole raised to the power of 4, which is equals to 3 will get cancelled. Minus 5 raised to the power of 4. We got the result in power notation with a positive exponents. Now let's move to the fourth one. 3 raised to the power of minus 7 divided by 3 raised to the power of minus 10 into 3 raised to the power of minus 5. Now let's solve this fraction. 3 raised to the power of minus 7 minus of minus 10 into 3 raised to the power of minus 5. This will be 3 raised to the power of minus 7 plus 10 into 3 raised to the power of minus 5, that is equals to 3 raised to the power of 3 into 3 raised to the power of minus 5, which is equals to, this time the bases are same, So let's write the base. Since it's multiplication, let's add the exponents. This will be 3 raised to the power of 3 minus 5, which is equals to 3 raised to the power of minus 2. We have got the result in power notation but not with the positive exponents. Let us convert minus 2 into plus 2. For that which we have to reciprocate the base 1 by 3 raised to the power of 2. We have simplified it. We don't need to find the value of 1 by 3 raised to the power of 2. Let's move to the fifth one. 2 raised to the power of minus 3 into minus 7 raised to the power of minus 3. Since the exponents are same, let's group the base. 2 into minus 7 whole raised to the power of minus 3. This is equals to minus 14 raised to the power of minus 3. We have got the result in power notation but not with a positive exponent. So let's convert it into positive exponent. This is equals to 1 by minus 14 raised to the power of 3. We have simplified it. It's enough. Now let's summarize what have we learned in this session. In this session, we have learned the meaning of powers and exponent. Power is the combination of exponent and the base, whereas exponent is not called as power. Laws of exponent are the multiplication, division, and law of exponent where the exponent is negative. Conversion of large numbers into exponential form, that is standard form. We even learn the conversion of even small numbers into exponential form, where we will have a negative exponent. And we have solved some of the questions of exercise 2.1. Meet you in next session of this same topic, exponents and powers. Till then, take care. Bye.